Hello everyone. Welcome to my YouTube channel Chemistry Quest. This is the sixth lecture in the series of biomolecules chapter. In this video, we will be discussing what are disaccharides in detail. So, disaccharides on hydrolysis with acids or enzymes yield two molecules of either the same or different monosaccharides. The two monosaccharide units are joined together by an oxide linkage formed by the loss of water molecule, and this linkage between two monosaccharide units through oxygen atom is called glycosidic linkage. So next, in disaccharides, if the reducing groups of monosaccharides, that is aldehyde groups or ketonic groups, are bonded, they are called non-reducing sugar. So example is sucrose. Sucrose is a non-reducing sugar. That means it does not give tolerance test as well as Benedict's test as well as Felling's test. And on the other hand, sugars in which these functional groups are free, they are called reducing sugars. For example, maltose and lactose. So they are called reducing sugar because they give the tolerance test, Benedict's test, as well as the Felling's test. Now see the reaction. So sucrose on hydrolysis, it is giving two molecules. One is the glucose molecule and the second one is the fructose molecule. And the glucose molecule is dextrorotatory, whereas the fructose molecule is levorotatory. So here we have to see one more term, invert sugar, that we will discuss later. So, some points about sucrose is it is on hydrolysis gives equimolar of mixture of D plus glucose and D minus fructose. Since the reducing groups of glucose and fructose are involved in glycosidic bond formation, sucrose is a non-reducing sugar. That means it does not give tolerance test, it does not give Benedict's test, it does not give Felling's test. Now, how the sucrose molecule is formed? So, this is the alpha D glucose and this is beta D fructose. So, what happens here? The first carbon here, the OH is there, and here also in the second carbon, here OH is there. So, the OH group from the alpha D glucose and H from the beta D fructose is removed and exists as water molecule, and thereby a glycosidic linkage, that is this is bond is forming between 1 and 2 with the oxygen atom. So this is a glycosidic linkage. So this is a sucrose molecule. Now next we have to deal with the summary that the two monosaccharides glucose and fructose are held together by a glycosidic linkage between C1 of D glucose, that we have already seen, and C2 of beta D fructose. This we have to remember ki sucrose has the glycosidic linkage between C1 of D glucose and C2 of beta D fructose. Sucrose is dextrorotatory, but after hydrolysis gives dextrorotatory glucose and levorotatory glucose. This is very important concept here. So what happens in the beginning, sucrose is dextrorotatory. That is, it rotates the plain chloralized light towards the clockwise direction. But what happens when it is hydrolyzed? It gives dextrorotatory glucose and levorotatory fructose. So the glucose dextrorotation of glucose is plus 52.5 degree, whereas the levorotation of fructose is minus 92.4 degree. So if we see, ignoring the negative and positive sign, 92.4 is highest. So the sucrose molecule, which was dextrorotatory in the beginning, it becomes levorotatory at the end of the reaction of hydrolysis. So hydrolysis of sucrose brings about a change in the sign of rotation from dextro to levo, and the product is known as invert sugar. Now next we have to study about maltose. So maltose is a very simple disaccharide in which there are two alpha D glucose units joined together by C1 of one glucose and C4 of another glucose unit. There are both the units are glucose units, that too alpha D glucose. That is very important. So the free aldehyde group can be produced at C1 of second glucose in solution, and it shows reducing property, so it is a reducing sugar. So how the structure is, so alpha D glucose, as I have already mentioned. So here alpha D glucose, here OH will be there, and here also OH will be there. So in maltose you have to take -1 mole of water from one alpha D glucose and alpha D glucose. Both are similar units. There is no difference units. As in case of sucrose, one was glucose unit and other was a fructose unit. Here both are same unit, and the linkage is C1 to C4 oxide linkage, that is known as glycosidic linkage. Now next is lactose molecule. So lactose is a sugar mainly found in milk. So it is composed of beta D galactose and beta D glucose. That is very important. It is a beta sugar. The linkage between C1 of galactose and C4 of glucose. So free aldehyde group may be produced at C1 of glucose unit, hence it is called a reducing sugar. So lactose is a reducing sugar. So how the structure of lactose is, that we have to see. So first we have to remember what is a beta D galactose. So beta D galactose, how it is formed, you have to take the beta D glucose, and at 4 carbon here OH is there. So in beta D galactose this position is reversed. So in the fourth carbon H comes down and OH comes up. This is the galactose formation. So here what happens in lactose, the beta D glucose unit removes the OH unit. Here from here OH is removed, from here H is removed, so here minus water molecule. So in a way it is known as glycosidic linkage. So if you like the video, please hit the like button, share with your friends, and don't forget to subscribe to my channel, and also hit the notification bell for upcoming videos. Thank you.